Hey guys, the structure of the atom here. Thought I would put this together just to sort of reinforce the video that Miss Parente had made for you guys, so I hope you enjoy it. The atom is important here when we talk about chemistry because it really is the building block of all matter. And everything around you is made of matter, so everything around you is made of atoms. So the study of atoms is important. We're really going to be focusing in on the structure of the atom, how it's built, and what it's made out of. Just a reminder of what matter is. Matter is anything that has mass and takes up space. There are two main parts of an atom. We have the nucleus, which is the center, and the electron cloud, which is all of the area outside of the nucleus. This picture here of an atom on the right-hand side is a older model of an atom. We see these a lot when we just Google an image of an atom. You can see the nucleus in here, and then you have your energy levels out here, and it shows the electrons. This one's good because it kind of shows you the little bit of a line out here, shows you the movement of electrons. And the electrons are moving around the nucleus, so this is kind of a good representation. This one over here is actually the most modern, I guess, updated kind of model of the atom. It's known as the electron cloud model. What it shows you, again, is the nucleus in the center. And then it shows you just sort of a fuzzy kind of blurry area around here. These are all electrons. And when electrons are moving really fast around the nucleus, you can't really focus on one at any given moment because they're just moving so fast. So what you end up seeing is just this blur. And that's why they call it an electron cloud, because it looks more like a cloud than it does anything else. I do want to make sure that you remember from a video you watched earlier that most of this electron cloud is empty space. We just have electrons that are orbiting the nucleus at certain distances from the nucleus in the energy levels, which we'll talk about more in just a little bit. So the nucleus here in the center of our atoms contain two of the three subatomic particles. All atoms are made of the proton, the neutron, and the electron. You can see from our picture here that the nucleus contains the protons, the red ones, and the neutrons, the little blue ones. The electrons then are found out here outside of the nucleus in the electron cloud. Get it? The electrons are in the electron cloud. And they are the particles that, again, move around, fly around, orbit around the nucleus in those energy levels. And you can see here this particular atom of lithium has two energy levels, an energy level here and here. Energy levels can also be known as orbitals or shells or rings. There's a lot of different words we can use to describe the areas in the electron cloud where the electrons move. What do you think the little sign here, a little positive sign inside the proton, and the little negative sign out here in the electron represent? Yes, you're right. It is the charge of the particle. Protons have a positive charge, positive, and electrons have a negative charge, negative. But what about the neutron? Do you see a charge in there? That's right, no charge. So neutrons do not have a charge. So let's review. A proton has a positive charge. A neutron has no charge. And an electron has a negative charge. The mass of a proton is 1 AMU. Now, an AMU, that's a new unit. We haven't seen that unit yet. We've seen all kinds of units, meters and newtons and joules and all kinds of things. But this, AMU, is the unit for atom mass. We can't measure the mass of a proton in grams because grams or even milligrams are way too big to measure something so teeny tiny. And so they came up with a brand new unit to measure the mass of these very small particles. And so a proton has a mass of what's known as 1 AMU, atomic mass unit. A neutron also has a charge of 1 AMU, and electrons have a charge of 0.001 AMU. When you look at a model of an atom, one of the misconceptions is that the protons, the neutrons, and the electrons are all the same size and that they all contribute to the atom's mass. But looking here at the mass, you can see that the protons and the neutrons are the same mass, therefore they are about the same size within an atom's nucleus, but the electron out in the electron cloud with a mass of only 0.001 AMU is so tiny. They're very small, the electrons are, when compared to the size of a proton and a neutron. As we already know, the proton is found inside the center nucleus with the neutrons, and the electrons are then flying around the electron cloud. So let me ask you a few things. Where, based on this information, is most of an atom's mass located? What location within an atom are we going to find the majority of an atom's mass? Well, I hope you said the nucleus, because the protons and the neutrons, both with a mass of 1 AMU, are found in the nucleus, and that is where most of an atom's mass will be located. So do electrons contribute to the overall mass of an atom with the mass of 0.001 AMU? Do they contribute to the overall mass of the atom? Well, the answer is no. No, they don't. Think about it for a second. The largest atom known has 200 electrons. Imagine that. Let's say 200 protons, let's say 200 neutrons, and 200 electrons. So that's 200 protons, 200 AMU, and 200 neutrons, 400 AMU, and then 0.2 AMU from the electrons. Seriously? 400 atomic mass unit versus 0.2? I don't think the electrons contribute to the overall mass at all because their mass is so tiny. Got it? If not, ask me about it in class tomorrow and I'll talk about it some more. So how can I determine, I being you, because I already know how to do it, how can I determine the number of protons, neutrons, and electrons that an atom has? Use the periodic table, that awesome tool that all chemists use. The periodic table is composed of all of those element boxes, and the element boxes give us a lot of information. They tell us the element name. They tell us the element's atomic number. Now, what is the atomic number? Now, inside of this element box, the atomic number is at the top, but the atomic number might not always be at the top of all periodic tables. But the atomic number will always be the whole number. So whether it's at the top or the bottom, the whole number represents the atomic number. And the atomic number represents the number of protons in an atom. I said protons, the number of protons. Let me say that one more time. The atomic number is the number of protons in an atom. Now, atoms that have a neutral charge, neutral meaning no charge, so the positive protons in the nucleus, the negative electrons in the electron cloud, if the number of positive charges in the nucleus equal the number of negative charges in the electron cloud, then the overall charge of the atom will be 0 or neutral. In 8th grade, all of the atoms we study will be neutral atoms. So the number of positive protons will always equal the number of negative electrons. So if our atomic number is the number of protons, then for us it will also be the number of electrons. But that's only true if it's a neutral atom. And when you get into chemistry, you're going to start studying atoms that have a charge. They're called ions. And ions do not have the same number of protons and electrons. But again, for our purposes, neutral atoms will always have the same number of protons and electrons. So the atomic number is the number of P's and the number of E's. The symbol is also going to be found on the periodic table. And some guys have already been asking me why the second letter is lowercase. Well, that's just the rule. It's not my rule. I didn't make it up, but it is the rule of chemistry. When you look at an element symbol, if the symbol consists of one letter, then that letter will be capitalized. But if it consists of two letters, the first letter will be capitalized and the second letter will be lowercase. And then this decimal number down here, which could be at the top or it could be at the bottom, but it's always the decimal number. That's going to be the atomic mass number. And the atomic mass number, remember where all the mass comes from? It's in the nucleus, and that's where all the protons and neutrons are. So when we total the number of protons and neutrons in the nucleus, that gives us the atomic mass. Now, Mr. Burris, of course, Mr. Burris, because he's a man, uses this trick to help you calculate the number of neutrons, and it's called MAN. You take the mass number of your element, you subtract the atomic number, and what's left over is the number of neutrons. So let's try and figure out how many. If the atomic number of carbon is 6 and the mass number is 12, how many protons, electrons, and neutrons will an atom of carbon have? Well, if the atomic number is 6, then it should have 6 protons, and if it's a neutral atom, it will have 6 electrons as well. And then I take the MAN, 12 minus 6 is 6. So 6 protons, 6 electrons, and 6 neutrons. Try boron. Atomic number 5, 5 protons, 5 electrons, if it's neutral. MAN, mass number, minus atomic number, gives me the neutrons. So 5, 5, and 6. Try oxygen. Atomic number of 8, number of protons should be 8. If it's a neutral atom, the electrons will be 8. If the mass number is 16, MAN, 16 minus 8 is 8. All right. Notice that carbon and boron both have the same number of neutrons. Does that mean that they're the same atom? Absolutely not. The particle that determines an atom's identity is the number of protons. If it has 6 protons, it's carbon, no matter how many neutrons it has. If it has 5 protons, then it's going to be boron, no matter how many neutrons it has, or electrons for that matter. If it has 8 protons, it's oxygen, no matter how many electrons or neutrons an atom has. It's because it's the number of protons that determine an atom's identity. The atomic number of protons. Remember the Bohr models we were using earlier in class? It's nothing more than a graphic representation of an atom because it helps us study something that's too small to see. Now, when you're building Bohr models, there are some rules you need to remember about the electrons. The first energy level, the one closest to the nucleus, that energy level, orbital, ring, shell, however you want to call it, can only hold 2 electrons, maximum 2. It can't hold 3 or 4 or 5. It can hold 1, it can hold 2, but it can't hold more than 2. The second level is maxed out at 8. So it can hold 1, 2, 3, 4, 5, 6, 7, or 8, but it can't hold more than 8. The third level is also maxed out at 8. And the fourth level, if a fourth level is needed, because we know that the largest atom is going to have 7 energy levels. We're not going to go that far. We're going to stop at 4. The fourth energy level is considered full at 8. It can actually hold 18, but it's considered full at 8. Electrons will not begin filling out the next energy level, though, until the energy level below it is full. So an atom isn't going to have 1 electron in the first shell and then start filling in the second shell. The first shell has to be filled up before electrons will start filling up the next shell. And remember, valence electrons are found in the outermost energy level. So whether it has 1 ring, 2 rings, 3 rings, 4 rings, 7 rings, the number of electrons in the outermost ring will be the valence. So let's try and practice a few Bohr models. What would an Bohr model or an atom of sodium look like? Well, if sodium has 11 protons and 12 neutrons, and I figured that out by looking at my periodic table, then inside the nucleus I'm going to have 11 protons and 12 neutrons. If sodium has 11 electrons, I will put those electrons into the electron cloud. I first start by filling up level number 1. 1, 2 electrons. Now that the first energy level is filled, I go to the next one. 2, 3, 4, 5, 6, 7, 8. That's full, so I go to the next one. 1, 2. Oh, excuse me. 1. And so 11 electrons, 2 in the first level, 8 in the next level, 1 in the last level. I add the protons and the neutrons together to get the atomic mass of 23. It has one electron in its outer shell, therefore it has one valence. I'm almost running out of time, so let's quickly do oxygen. 8 and 8, put them there. 8, 1, 2, 3, 4, 5, 6, 7, 8. The atomic mass is 16. I have six electrons in the outer shell, and then 6 is the valence number. Your action item is to turn your wicks over and make a Bohr model of aluminum. I will see you tomorrow.